Good morning, everyone. Our lesson for today is about the physiologic value of the food. Okay, what are our objectives? At the end of the discussion, the student should be able to number one, calculate the physiologic value of the food, and number two, to compute the desirable body weight and the energy needs of an adult. Okay, so let's have a review about the food. Food is very essential for our normal functioning. Generally, these foods are converted into significant nutrients needed by the body. Okay, it refers to the solid and liquid materials taken in the digestive tract that are utilized to maintain and build body tissues, regulate body processes, and supply heats, thereby sustaining life. Okay, food is composed of various compounds, both organic and inorganic, so that any food is either a chemical compounds or a mixture of chemical compounds. These compounds and elements can be grouped as either organic or inorganic. Okay, organic compounds, these are the proteins, lipids, carbohydrates, and vitamins. Inorganic elements are, of course, the water and the minerals. Okay, the three major nutrients, which are the carbohydrate, proteins, and fats, stand quite apart from the other requirements of the body, such as vitamins and mineral, since the former are needed in comparatively larger quantities. Okay, vitamins and minerals act as catalysts which prompt the three major nutrients to interact. Okay, let's have a review about the metabolism. Okay, metabolism derived from the Greek word metabolismus, which means to alter or to change. Okay, metabolism is the chemical process of transforming food into complex tissue elements and of transforming complex body substances into simpler ones along with the production of heat and energy. It is the totality of the chemical processes in the body by which substances are changed into other substances to sustain life. Thus, it is the dynamic concept of change and underlying all life. Okay, so for us to function or do our activities, we need energy. So energy is the force or power that enables the body to do its work. Okay, in nutrition, however, energy pertains to the chemical energy left in the foodstuffs brought about by metabolism. Okay, energy from food. Okay, let's talk about the calorie. Okay, calorie is the unit of energy commonly used in human nutrition, or is kilogram calorie or kcal or simply calorie. Okay, so it is the unit of measurement for the energy that the body gets from the food. Okay, 1000 small calories is equal to 1 kilocalories or calorie. Okay, calories are not eaten. They are byproducts of carbohydrates, protein, and fats that are oxidized in the body. 1 kilocalorie is the amount of heat energy required to raise the temperature of 1 kilogram of water by 1 degrees Celsius. Okay, fuel factor of the carbohydrate is about 4 calories per gram. For the fats, we have 9 calories per gram. For the protein, we have 4 calories per gram. Okay, so the total calories content or the total energy available from food can be measured by a device called the BAM calorimeter. Okay, so that is the picture of a BAM calorimeter, the device to measure the total calorie content available from the food. Okay, the other term that we are going to define is about the joule. The joule is the measure of energy in the metric system. Okay, 1 1 calorie or kilocalorie is equal to 4.184 joules or kilojoules. Okay, for example, 1 cup of milk is equal to 170 kilocal. So 170 kilocal times 4.184 kjoules is equal to 711.28 kjoules. Okay, so calculation of food value. The energy value of 1 tablespoon of sugar, 15 grams, is approximately 60 calorie. So 15 times 4. So that's how we are going to arrive with the um, food value of a sugar. Most food, however, are complex and contain protein, fats, and carbohydrates. Okay, like for the example, 1 cup of milk contains approximately 12 grams of carbohydrates, 8 grams of protein, and 10 grams of fats. So 12 grams multiplied by 4 kilocal per gram, we have 48 cal or kilocal for the carbohydrate, and 8 grams for the protein multiplied by 4 calorie per gram, we have 32 kilocal. Then 10 grams of fats multiplied by 9 cal per gram, we have 90 kilocal. So a total of 170 kilocal. Okay, so to determine the percentage of each nutrients, we have to, for example, the 90 kilocal fats. Okay, we have to divide it into 170 kilocal. So we have arrived with 0.529 or 0.53, then multiplied it by 100. So we have 53% of fats contained a cup of milk. Okay, what are the energy allowance for adult 22 years old of age or 22 years of age? Okay, for the 40 kilograms, okay, for the women we have 1550 kilocal. For kjoules we have 6500. Okay, so for a 45 kilograms, for the women, we have 1,700 kilocal and we have 7,100 kjoules. Okay, so this table shows you the energy allowances for an adult 22 years old or 22 years of age. Okay, let's move with the component of energy expenditures. Okay, so our body expends 70% of energy for the basal metabolic rate, and we have for the physical activity we have 20%, and for the thermogenesis we allotted 10% of it. So yung basal metabolic rate medyo malaki. Okay, ang energy na ginagamit nito. Okay, so let's talk about the basal metabolic rate. Basal metabolic rate is also known as the RE or the required REE, the required energy expenditures. Okay, it is the measure of energy needed by the body at rest for all its internal chemical activities, which is approximately 1 calorie per kilogram of body weight per hour of an adult. Okay, the rate of basal metabolism in a given person at a given time and situation, okay, it constitutes 1/2 of the calorie requirement of an individual. Okay, so it also indicates the amount of energy needed to sanction the life processes like respiration, cellular metabolism, circulations, glandular activities, and the maintenance of the body temperature. Okay, it accounts for more than 1/2 of calorie requirements for most people. Okay, basal metabolic rate test. Okay, to ensure accuracy, okay, how the BMR test is conducted. So number one, the subject must be in the fasting or post-absorptive state at least 12 hours after meal. That is usually taken in the morning. Okay, the subject or the person or the individual must be aware, lying quietly and free from any physical fatigue, nervousness, or tension, as this causes an increase in heat production. Okay, number three consideration, the environment temperature should be between 20 degrees Celsius to 25 degrees Celsius so that the subject can maintain his or her body temperature. Okay, the value obtained in this test, which are within the plus or minus 10%, are still considered normal. Okay, how we're going to calculate our basal metabolic rate. Okay, there are four methods in order to calculate the basal metabolic rate. We have the simple method, we have the Harris-Benedict formula, we have the one more method used to obtain the metabolic or fat-free body is called the biologic body weight raised to the 3/4 power, and the lastly is the method developed by the WHO. Okay, let's talk about the simple method. Okay, the simple method of calculation of the BMR is the use of the rule of thumb: 1 kilocal per kilogram per hour for an adult male and 0.9 kilocal per kilogram per hour for adult female. Okay, so thus an individual whose ideal weight or ideal body weight is 50 kilograms has a basal metabolic energy need of 1000 kilocal per day. So that is 50 multiplied by 1 kilocal times 24. So thus this value, however, may not be applicable for obese or lean individual. For example, for a male weighing 75 kilograms, okay, 1 kilocal multiplied by 75, the weight of the person multiplied by 24. So the person or the male who are weighing 75 kilogram has a BMR of 1,800 kilocal. And for the female, for example, 65 kilograms ang weight niya. So 0.9 kilocal multiplied by 65, then multiplied by 24. So this 65 kilogram female has a BMR of 1,404 kilocal. Okay, the another method is the Harris-Benedict formula developed in the year 1909, which uses information on weight, height, age, and of course gender. Okay, so these are the formula for the male. For the required energy expenditure, we have 66 multiplied by 66 is given. Okay, it is constant. So 13.7 multiplied kung ilan yung weight, tapos then 5 multiplied by kung ilan yung height niya in centimeter, then 6.8 multiplied mo siya kung ilang taon na siya. So 66 plus kung ano yung nakuha mo doon sa first part, then i-add mo yung sa may second part for the height, then isusubtract mo siya dun sa nakuha mo dun sa may last part. Okay, same with the female, but then again the constant, magkakaiba sila ng value. Okay, so constant sa kanya yung 655, and for the weight 9.6 naman, and for the height 1.8, and for the age 4.7. Later on we have example on the next slide. Okay, on how we are going to compute the BMR using the Harris-Benedict formula. Okay, next is the one more method used in obtaining the metabolic or fat-free body size is called the biologic body weight raised to the 3/4 power. Once the metabolic body size is known based on the weight in kilograms, the figure is multiplied by 70, a value which appears to all animal. Okay, so example. So for a 50 kilogram man, okay, REE is equal to 18.8 times 70. So for a 50 kilograms, if you can see for the body weight in kilograms and metabolic body size, kilograms to the power of 3/4. So under 50 kilograms, we have the metabolic body size of 18.8. So for a 50 kilogram man, okay, for the REE or for the basal metabolic rate is equal to 18.8 multiplied by 70. So we are going to arrive with 1,326 kilocal. Okay? So very important dito yung table kasi dito natin madedetermine yung metabolic body size for the power of 3/4. Okay? The last method is developed by the WHO, the Food and Agriculture Organization, and the United Nations University. Okay, 1.6 multiplied mo kung ilang kilogram ka, then i-add mo siya ng 1,379. Okay, that's your basal metabolic rate. So 50 kilograms man has the basal metabolic rate of 1,459 kilocal. Okay, so that's how you're going to compute your basal metabolic rate. Okay, moving on, what are the factors that affect the basal metabolic rate? Okay, we have identified 8 factors. Okay, number 1 is the surface area. Okay, the greater the body surface area or skin area, the greater the amount of heat loss, and in return, the greater the necessary heat produced by the body. Muscle tissue requires more oxygen than adipose tissue. Okay, for the gender, women in general have a metabolism of about 5% to 10% less than that of the men, even when they are of the same weight and height. Okay, so mas mababa ang metabolism ng mga female counterparts, okay, compared for those men. Okay, women have a little more fat and less muscular development than of those men. Okay, for the age, the metabolic rate is higher during the periods of rapid growth, chiefly during the first and second years, and reach a lesser peak through the age of puberty and adolescence in both sexes. The BMR declines slowly in increasing age to lower muscle tone and from lessened activity. Okay? So, as we grow, mas mataas yung ating metabolism. Okay? So, ganun din pag medyo tumatanda na tayo, medyo bumababa na ang ating metabolic rate. Okay, for the body composition, a larger proportion of inactive adipose tissue lowers the BMR, the basal metabolic rate. Athletes with great muscular development shows about 5% increase in basal metabolism over non-athletic individual. Okay, another factor is the state of nutrition. Okay, a decrease in the mass of active tissue, such as the case of undernourishment or starvation, cause a lower metabolism, often as much as 50% below the normal. So, kaya nga yung mga undernourished natin, siyempre, mas mababa yung kanilang metabolism. Okay, sleep. Okay, isang factor din po yan. During sleep, the metabolic rate falls approximately 10% to 15% below that of waking levels. Okay, this decreased rate is due to the muscular relaxation and decreased activity of the sympathetic nervous system. Okay, endocrine glands. The endocrine glands, which secretes the hormones, okay, into the body stream, are the principal regulators of the metabolic rate. The male sex hormones increase the basal metabolic rate about 10% to 15%, and the female sex hormone a little less. Okay, fever, of course, fever, it increases the basal metabolic rate of about 7% for each degree rise in the body temperature, about 98.6 degrees Fahrenheit. Okay, that these are the factors that affect the basal metabolic rate of an individual. Okay, what are the components of energy expenditures, or how we are going to compute for the desirable body weight? Okay, so number one, we are using the Ador-Dionysius method. Okay, for the height, for every 5 feet, okay, allow 100 pounds for female and 110 pounds for male. Then you are going to multiply it, the additional inches, by 2. Okay, for the age, multiplied any age between 25 and 50 by 2 and divide it by 5. Okay, example. For a male 45 years old and has a height of 5 feet and 4 inches tall. Okay, for the height, 5 feet, we have 110 pounds and 4 inches, so multiplied it by 2. So you will going to arrive with 8 pounds. So if you are going to add it, 110 plus 8, we have 118 pounds. Okay, so segregate muna natin yon. Then for the age, the individual is 45 years old. So you have to multiply it by 2. Then divide it by 5. So we are arriving with the 18 pounds. Okay, so for the desired body weight, 118 pounds plus the 18 pounds is equal to 136 pounds. So if we are going to convert it in the kilograms, so 2.4, so 136 divided by 2.2. So your desired body weight for a 45 years old 5'4" tall is 61 to 62 kilograms. Okay, so that's how we are going to compute the desired body weight using the Ador-Dionysius method. Okay, moving on. Another is the Tannhäuser method. Okay, measures the height in centimeter and deduct it by 100. Okay, from the difference, take off its 10%. Okay, so example, for the male 45-year-old, 5'4" tall. Okay, for the height, we have 5 feet and 4 inches tall. We have 162.56 centimeters in, okay, if you are going to convert it. So 162.56, sabi dito, i-deduct natin yung 100. So 62.56. Then from that, okay, take off its 10%. So 10% of 62.56 centimeter is 6.256. So 62.56, okay, less mo yung 6.256, that is the desired body weight. So the desired body weight is about 56.7 kilograms or 126 pounds. Okay, that is the Tannhäuser method. Okay, physical activity. So the calorie expenditures from various types of activities. Okay, calorie requirements depends on the type and amount of exercise. The more vigorous the physical work, the greater the calorie cost. The kind of physical activity and the amount of time spent determine the amount of energy the body uses. Okay, as you can see, okay, on the table, for the type of activities and how much calorie you're going to expend. Okay, so for sedentary activities, reading, writing, eating, watching TV or office work, sitting at work, you are losing 80 to 100 calories. And for the light activity like cooking, washing dishes, ironing, welding, standing at work, or rapid typing, we have 100 to 160 calories. For the moderate activities like mopping, scrubbing, sweeping, gardening, carpentry, walking fast, standing at work, or with moderate arm movement, sitting at work with vigorous arm movement, we have 170 to 240 calories. For the heavy activities like heavy scrubbing, hand washing, walking fast, bowling, golfing, and heavy gardening, we have 250 to 350 expenditures or calorie expenditures. Okay, specific dynamic action of food or the SDA. So the carbohydrates and the fats increases the heat production of about 5% of the total calorie consumed. It is the energy required to digest, transport, and utilize the food. Okay, let's have to discuss about the estimation of daily energy requirement of an adult. So number one, you have to determine the desired body weight in kilograms of the individual. Then after that, so determine the basal needs or the basal metabolic needs. Okay, for the male, the formula, the simple method, we have the 1 kilocal per kilogram of desired body weight per hour multiplied by 24. Okay, for the female, we have 0.9 kilocal per um, kilogram of desired body weight per hour times 24. Then you're going to subtract 0.1 kilocal per kilogram of desired body weight per hour of sleep. Then add the activity increment. Then after that, find the SDA, 10% of the basal needs plus the activity increment. Then sum equals the approximately daily caloric requirement. Like for example, okay, let's take a look of the activity increment. Okay, this is the activity increment for the sedentary light uh, or light work. We have the activity increment of 222 kilocal per day, and for the moderately work we have 750. For the heavy work 1500. For the very heavy work we have 2500. This is for the meal. Okay, so for example, your desired body weight is 50 kilograms. Okay, so number two, determine the basal needs. So 1.0 kilocal per kilogram. So 50. So 1 kilocal times 50 kilogram multiplied mo siya sa 24. So you're going to arrive with 1,200. That's for the male. For example, the individual is a male and has a desired body weight of 50 kilograms. Then you're going to subtract 0.1. Okay, 0.1 multiplied by 50. So that's 5. Then multiplied mo siya dun sa desired body weight over the hours of sleep. So multiplied mo siya ng 8. So we have 40. So if you are going to subtract it, we have 1 2 less 40, so we have 1,160. Then add mo yung activity increment natin. For example, moderate work. Okay, so 1,160 plus 750, we have 1,910. So add the SDA, 10% of the basal metabolic needs. Ang ating basal metabolic needs kanina is 1,2. So the 10% of it is 120. So i-add mo yung 750 since we have identified that the individual has the moderate work kind of activity. So 120 plus 750, we have 970. So yung sum kanina na 1,910, i-add mo yung 970. So the daily energy requirement of an adult with desired body weight of 50 kilograms is 2,880 calories. Okay, estimation for the total energy need. Okay, the most practical and rapid method of estimating energy need is based on the desirable body weight. Okay, according to occupation. This method is often used in clinics and hospitals. Okay, for example, the occupation or the activity is bed patient, or lightweight, or moderate weight, or the heavyweight. Okay, for the female, we have 12. For the kilocal per pounds, for the kilocal per kilogram, we have 25, and so on. Okay, for example, okay, a 50 kilogram man, okay, with moderate active work, so multiplied mo yung 50 times 40, so you will arrive with 2000 kilocal per day. Okay, so the second method is the estimating the energy need in the factorial method. Okay, the basal energy, the physical activity, and the thermogenic effect of the food. That's the total energy need. So first, you have to calculate the basal metabolic rate using any of the four methods discussed earlier. Then number two, determine the energy need for physical activity by using the short method, calorie expenditure for various type of activities. Letter C, add the basal energy cost and the activity cost. And D, calculate the thermogenic effect of the food for a mixed diet, adequate in protein, add 10% of the subtotal. For the average Filipino diet, yet use 6%. So 6% ang gagamitin natin mamaya. Add the basal energy, physical activity, and the thermogenic effect of the food. Okay, for example, okay, basal metabolic rate using the Harris and Benedict formula. Okay, for the 66.5 plus, open and close, 13 multiplied by 50 kilograms plus, open and close, 5 times 157 centimeters less, open and close, 6.8 times 35, that's the age. So you'll arrive with 66.5 plus 685 plus 785, then less 238. So we have 299 kilocal for the basic metabolic rate. Okay, let's reserve that. Then for the energy need for the physical activity, we have the total physical activity kilocal multiplied by 50, weight in kilograms. So 17.24 kilocal multiplied mo siya sa 50. So we have 862 kilocal for physical activity. Okay, then moving on, the needs, energy needs, I'm sorry, that's letter C, the basal energy cost and activity cost. Okay, so 1,299 kilocal plus the 862 kilocal, we have 2,161 kilocal. Okay, that's the basal energy cost and activity cost. Okay. Okay, next is we have to compute with the thermogenic effect of the food. Okay, the basal energy cost plus the activity cost multiplied by 6%. So 1,299 kilocal plus the 862 kilocal multiplied by 0.06. Okay, so 2,161 multiplied by 0.06, we have 113. And lastly, the basal energy cost, activity cost, and the thermogenic effect of the food. Okay, so we have 1,299 kilocal plus the 862 kilocal plus the 130 kilocal. So we have 2,291 kilocal. Okay, that's the estimation of the total energy needs. Okay, so number 3, the daily energy need can also be determined by referring to the recommended dietary allowance for the Filipino. So recommended daily energy intake for an adult, okay, for the age 20 to 31. We have for the male, we have 2,580. For the women, we have 1,920. And for the 40 to 49 years old, we have for the male, we have 2,450 and 1,820 for the women. And for the 50 to 59 years old, we have 2,320 kilocal, and for the female counterpart, we have 1,730. For 60 to 69, we have 2,060 for the male and 1,540 for the female. Then for 70 to 79, we have 1,810, and for the women naman is 1,340. Okay? So, last, the fourth method is recommended by the WHO and the Food and Agriculture Organization. Okay, to get the energy need, multiply the REE by the type of activity. So, energy need based on the type of activity. Okay, for the very light, we have 1.3. For the light, we have 1.6. Moderate, 1.7. Heavy, 2.1. And very heavy, 2.4 for the male. And for the women, for the very light, 1.3. Light, 1.5. Moderate, 1.6 for the heavy activity, 1.9. Very heavy activity, we have 2.2. So for example, you have the basal metabolic needs of 50 kilograms man is 1,459 kilocal. Then multiplied mo siya for 1.7 because my moderate, we have arrived with 2,480 kilocal. Okay, next we have the body index. How we're going to compute with the body mass index. Okay, the formula is weight in kilograms over the height meter to square. Okay, the body mass index is the ratio of the weight and the height. For example, an individual who weighs 92 kilograms and is 175 centimeter tall would have a BMI of 92 kilograms over 1.75 to the power of 2. So the BMI is 70 at the 30. So the body weight and the height should be measured without shoes. Okay, take note of that. Okay, if we are going to take a look with the body mass index table, okay, for the patient, we have 92 kilograms and 175 kilograms. So, nasa normal pa ba siya? 30 ang kanyang body mass index. Okay, that's extremely obese na siya. Tama? Okay. So, how you're going to compute naman for the calories in IV feedings or the dextrose. Okay, for example, the D10 water, 1 liters for 12 hours. Okay, so 1,000 multiplied by 0.1 is equal to 100 ml. So, multiplied by 3.4, so the calorie per 12 hours is 340 kilocalorie. So, for 24 hours, we have 680 kilocal. Okay, so solve this. D5 water naman, 1 liter for 12 hours. So, how many kilocal absorbed in the body in 12 hours and how many kilocal absorbed in 24 hours. Okay, that ends our discussion. Okay, hopefully may natutunan kayo regarding the physiologic value of food. Okay, thank you.